Dear students, in this lecture we are going to see some of the discrete distributions and continuous distributions. In the discrete, we are going to study the binomial Poisson hypergeometric. In continuous, we are going to study uniform, exponential and normal. First we will see what is the application of this binomial distribution, otherwise what is the need of this binomial distribution. We will take one practical example that I will solve manually with the help of our concept of probability. Then I will tell you how the concept of binomial distribution will help us to solve this problem in a quick way. Let us consider the purchase decision of the next 3 customers who enter a store. On the basis of past experience, the store manager estimates the probability that any one customer will make a purchase is 0.30. Now, what is the probability that 2 of the next 3 customers will make a purchase? That problem is drawn in the form of a tree diagram. The first customer, second customer, third customer. When the first customer comes, there are 2 possibilities. He can go for purchase or not purchase. Purchase mentioned as the yes, success, failure. Okay. The second customer also may go for purchase, not purchase. Third customer purchase, not purchase. Now look at the first possibility. The first customer is purchasing, so success, success, success. That is yes, yes, yes. If you take x, look at the bottom of the slide. If x equal to number of customers making a purchase, so in this category all 3 customers, all 3 are going to buy. Look at the second possibility, success, success, failure. So in this, out of 3 customers, 2 customers yes, yes going to purchase. Like this we have displayed all possibilities. Now the problem is x, what is asked is 2 out of 3 customers what they have purchased. So number of customers making a purchase is how many possibilities there? 2 customers, 1, 2, 3. How we got this 3? It is nothing but your 3C2. The 3C2 is out of 3, what is the probability, what is the chance that 2 customers will buy? There will be a possibility of 3C2. So 3C2 is 3. Now we will see the first customer, all possibilities, purchase, purchase, no purchase, success, success. So success we know probability, we are calling it as a P, failure is 1 minus P. So it is a P square into 1 minus P, P is 0.30 whole square multiplied by 0.70, it is a 0.063. For second chance also, first customer may buy, second customer did not buy, third customer also buy. So it is success, failure, success. So P 1 minus P into P, again P square into 1 minus P 0.063. Third choice, no purchase, 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 F, S, S. So 1 minus P, P, P. So it is a P square 1 minus P 0.063. If I plot this one, see x possibility, this possibility is, see this possibility. When x equal to 0, then that means what is the chance that all 3 customers will not buy? That is this case 0.7, 0.7, 0.7. If I say x equal to 1, what is the probability that 1 customer will buy? If x equal to 2, what is the probability 2 customers will come? 2 customers will buy. If x equal to 3, what is the probability that 3 customer will buy? So we can do with the concept of probability manually like this. So the question is asked is this one, what is the probability that 2 customers will buy out of 3? So this is our probability distributions. So this we can do manually, but it will take lot of time. So here with the help of your binomial distributions, you can get right this all possibilities going back this way, NCX. So P of capital X, okay, 2 NCX P power X Q power n minus x, where n equal to 3, here x equal to 2, P is the probability success, Q equal to probability of failure. So this NCX will give you different combinations of that event to happen. So, this p power x, you see that always here p2 qn minus 2. So, this will give you the probability. So, that is the purpose of this binomial distributions. What is the property of this binomial distribution? Experiment involve n identical trials. Each trial has exactly 2 possible outcomes, success, failures. Each trial is independent of the previous trial. For example, in the previous case customer 1 may buy or may not buy, that is not depending upon the, for example, for the second customer his intention of purchase is not based on the previous customer. So, P is the probability of success on any one trial, the Q is probability of failure on any one trial. So, P and Q are constant throughout the experiment, this is an important assumption. So, X is the number of success in the n trials. There the previous case we have seen x equal to 2. So, the probability function as I told you, it can be written as NCX, that is nothing but n factorial divided by x factorial into n minus x factorial, p power x, q power n minus x. The mean of this distribution is mu equal to n into p, directly we are going to answer. So, you can find out nothing but using the concept of expected value. When you multiply this p of x with the x, so sigma of x into p of x, when you simplify you will get this formula. Similarly, variance directly it is we are going to use only the result, variance equal to npq, standard deviation is root of npq. Sometime there is ready-made table is there to find out binomial probability values. For example, n equal to 10, n is number of trials, x equal to 3, p equal to 0.4, n equal to 10, x equal to 3, that value is this one 0.150. So, the tables are provided, you need not use your calculator, it may take more time. Now, we will find out mean and variance. Suppose for the next month the clothing store forecast 1000 customers will enter the store, in the previous problem there are 1000 customers. So, what is the expected number of customers who will make the purchase out of 1000? So, the answer is mu equal to n into p. So, n is 1000, probability of success is 0.3, so it is equal to 300. So, that is out of 1000 customers there is a chance that 300 customers will make the purchase. Okay. For the next 1000 customers entering the store, the variance and standard deviation of the number of customers who will make the purchase can be written as NPQ. So, n is given, p is given, 1 minus p is 70 to 10. The standard deviation is 14.49. Then we will go to next distribution, Poisson distribution. Describes discrete occurrences over continuous or interval. Generally Poisson distribution is for rare events. It is a discrete distribution, x can have only few discrete values. Yes, it describes the rare events. Each occurrence is independent of any other occurrences. The number of occurrences in each interval can vary from 0 to infinity. The expected number of occurrences must hold constant throughout the experiment. These are the assumption of Poisson distribution. Some of the examples are application of Poisson distribution. So, arrival at the queuing system follow Poisson distribution. Any airport, people may arrive, airplane may arrive, automobile may arrive, baggage may arrive, that follow Poisson distribution. In the banks, people, automobiles, loan applications, this arrival pattern follow Poisson distribution. In computer file services, read and write operations will follow Poisson distribution. The defects in manufacturing goods can be considered an example of Poisson distribution. For example, number of defects per 1000 feet of extruded copper wire. See that the n is very large, the probability of success is very low. Another example of Poisson distribution is number of blemishes per square foot of painted surface. Blemish is kind of a defect in paint. Number of errors per typed page. These are the example of your Poisson distributions. So, the probability function for Poisson distribution is lambda power x e power minus lambda divided by x factorial. where x can take only discrete value. The lambda is mean, that is a long run average. The value of E is 2.71. The mean of this Poisson distribution is lambda, variance of the Poisson distribution is lambda, standard deviation of Poisson distribution is root of lambda. So, this distribution called univariate distribution because it has unique parameter. That means it is a special property of a Poisson distribution where mean and variance is same. So, that is mean and variance is same, that is lambda. And another caution while using Poisson distribution is the unit of this lambda and x should be same. For example, lambda equal to 3.2 customers for 4 minutes, probability of having 10 customers in 8 minutes. So, you have to adjust the lambda. How will you adjust? You multiply by 2. So, it will be 6.4 into 8. Now, the unit of x and lambda is same, then you can use your probability function p of x equal to lambda power x in e power minus lambda. When substitute x equal to 10, we are getting 0.025. See the second one, lambda equal to 3.2 customers by 4 minutes, x equal to 6 customers for 8 minutes. So, you have to multiply lambda. So, it will be 6.4 into 8, then p of x will get the answer. So, what is the point here is the unit of lambda and x should be same. Here also there is a probability, Poisson probability table is available. So, when mu equal to 10, x equal to 5, you see in the column shows mu. So, mu equal to 10 here, x equal to 5 is this value. So, this value is 0.378. So, you need not use your calculator, directly you can read it from the table, but we are going to use these things in our practical class. We are going to find out probabilities with the help of Python. Then we will go for hypergeometric distribution. See, the binomial distribution is applicable when selecting from finite population with replacement or from an infinite population without replacement. So, whenever the concept of without replacement comes, then we have to think of using hypergeometric distribution. The hypergeometric distribution is applicable when selecting from a finite population without replacement. The properties of hypergeometric distribution. So, sampling without replacement from a finite population, then you should go for hypergeometric distribution. The number of objects in the population is denoted as capital N. Each trial has exactly 2 possible outcomes, success or failure, similar to binomial distribution. Trials are not independent. This is one different property when compared to binomial. In the binomial distributions, since we are going with replacement, the trials are independent. Here you are going without replacement, so the trials are not independent, it is dependent. Then that means the p will not be fixed, the probability of p will not be fixed, every time you will get different answer for the p. X is the number of success in the n trials. The binomial is acceptable approximation, capital N divided by n is greater than or equal to small n, otherwise it is not. Then we will see the probability function. If it is a discrete, we will use probability mass function. If it is a continuous, we will use PDF, probability density function. So, the probability mass function is p of x equal to ACX n minus a c n minus x divided by capital NCN. So, here see the capital letters represent for the population. So, n is capital N is for population size, capital A is the number of success in the population. Small letter small n is for the sample size, the x is number of success in the sample. So, p of x is ACX n minus a c n minus x divided by NCN. The mean value is a multiplied by n divided by capital N. The variance and standard deviation of hypergeometric distribution is a n minus a n into capital N minus 1 divided by n square into n minus a root of sigma square is the formula for standard deviation. We will see one problem here. Different computers are checked from 10 in the department. 4 out of 10 computers have illegal software loaded. What is the probability that 2 of the 3 selected computers will have illegal software loaded? By looking at the problem, we are feeling that it is a finite population. Okay. Whenever there is a finite populations, we should think of hypergeometric distribution. So, capital N is given, that capital N is your population size. Capital A is 4, because we know 4 is out of 10, 4 computers have illegal software, because we know the how much illegal software is installed in the population, A equal to 4. Then what is the probability that X is 2 of the 3 selected computers will have illegal software loaded. So, X equal to 2. Here small n is 3. There are two things is there, one is for the population. In population capital N equal to 10, capital A equal to 4. For the sample N equal to 3, then what is the probability of that 2 out of 3 selected computers will have illegal software loaded. So, when you substitute it, everything is given, so you will get 0.3. So, what is the meaning of this 0.3? The probability that 2 of the 3 selected computers will have illegal software loaded is 30%. Then we will go to the continuous probability distributions. A continuous random variable is a variable that can assume any value in the continuum, that is, can assume an uncountable number of values. Thickness of an item, time required to complete a task, temperature of a solution, height, these are example of continuous random variable. These can potentially take any value depending only on the ability to measure precisely and accurately. First we will see uniform distribution. The uniform distribution is a probability distribution that has equal probabilities for all possible outcomes of a random variable. That is the probability of random numbers also. When we say random numbers, the probability of choosing any number is same. Because of its shape, it is also called a rectangular distribution. Look at this uniform distribution. The uniform distribution is defined in interval a less than or equal to x less than or equal to b. So, the probability function is 1 divided by b minus a, where b is upper limit, a is the lower limit. In other interval, the value of f of x is 0, the area equal to 1. The mean of a uniform distribution is mu equal to a plus b divided by 2, standard deviation is b minus a divided by root of 12. This very standard result, the derivation of this one you can refer some textbook. Now, we will see some problem using uniform distribution. Suppose an uniform probability distribution over the range is defined this way, 2 less than or equal to x less than or equal to 6. So, if we want to know f of x, we know that 1 divided by b minus a, b is 6, a is 2. So, 1 divided by 6 minus 2 is 0.25. Okay. What is the meaning of this 0.25 means? In between 2 and 6, you can select any random variable, maybe 3, you may select 3 or 4 or 5. The probability of choosing 3 or 4 or 5 is 0.25. So, the mean is a plus b by 2 4, a is 2, b is 6, 8 divided by 2 is 4. Similarly, standard deviation is b minus a whole square divided by 12, that is 1.17. We will see another example. Suppose a random variable is defined between 41 to 47. First we have to find out probability density function 1 divided by b minus a. So, 47 minus 41. So, that is 1 by 6. So, 1 by 6 is the height. The height of this rectangular distribution is 1 by x. This value is your 1 by 6. The lower limit 41, upper limit 47. Okay. So, the mean of the distribution is 41 plus 47 divided by 2. So, 88 divided by 2, 44. Standard deviation is b minus a root of 12. So, 47 minus 41 root of 12 is 3.464, it is 1.732. Now, see the uniform distribution is defined in this interval 41 to 47, right. Suppose we want to know the probability between 42 and 45, is it 42 and 45. So, that can be done by 45 x, that is x2 minus x1 divided by b minus a, x2 is 45, x1 is 42. So, 45 minus 42 is 3 divided by 6. 3 divided by 6, it is 1 by 2. So, this area is 0.5. You will see another example of this uniform distribution. Consider a random variable x representing the flight time of an airplane travelling from Delhi to Mumbai. Suppose the flight time can any value in the interval between 120 to 140 minutes. Because of the random variable x can assume any value in the interval, x is a continuous rather than a discrete random variable. Let us assume that sufficient actual flight data are available to conclude that the probability of a flight time within any 1 minute interval is the same as the probability of a flight time within any other 1 minute interval contained in the large interval from 120 to 140. So, that is the properties of your uniform distribution. That means, in any small interval you should have the same value. If any one interval, if any between this interval, the probability will be same. Next another 1 minute interval, the probability is same. With every 1 minute interval being equally likely, the random variable x is said to have a uniform probability distribution. So, the upper limit is 140, lower limit is 120. So, 1 divided by 140 minus 120 is 20. So, the height of this rectangular distribution is 1 divided by 20. It is starting a value is 120, b value is 140. Suppose you are asked to find out probability of a flight time between 120 and 130 minutes. Suppose somebody is asking what is the probability of that flight arriving between 120 and 130 minutes. So, what you have to do, this is 130 minus 120 divided by 140 minus 120. When you simplify, you will get 0.50. So, the probability of that flight arrive between 120 130 minutes is 50%. Next, we will go to the exponential probability distribution. The exponential probability distribution is useful in describing the time it takes to complete a task. The exponential random variable can be used to describe the time between vehicle arrivals at a toll booth, time required to complete a questionnaire, the distance between major defects in a highway. For example, whenever the time between arrival and time required to complete the questionnaire, whenever the word between comes, then that is then it is appropriate to use exponential distribution. The density function for a exponential probability distribution is f of x is equal to 1 divided by mu e to the power minus x divided by mu. Mu is the mean. We will see what is how to construct an exponential distribution. Suppose that x represents the loading time for a truck at a loading dock and follows such a distribution. If the mean or average loading time is 15 minutes, mu equal to 15, then appropriate probability density function is f of x equal to 1 divided by 15 e to the power minus x divided by 15. So, what is the meaning of this exponential distribution is, suppose if the loading time, the probability of loading time less than 6 is this area. The probability of loading time between 6 and 18 is this one, this time. This is the probability. This shaded portion represents the probability of that loading time is between 6 and 18. Because in many application of exponential distribution, we will use the cumulative probability density function. So, for a exponential distribution, the formula for finding the cumulative probability density function is 1 minus e to the power minus x naught divided by mu, where x naught is some specific value of x. It is nothing but if you integrate that distribution, between the interval, when you simplify it, you will get this answer. Okay. We will see one example of this exponential probability distribution. The time between arrival of a cars at a petrol pump follows an exponential probability distribution with a mean time between arrival of 3 minutes. See that it is mean time between arrivals. So, the mean is 3 here. The petrol pump owner would like to know the probability that time between two successive arrival will be 2 minutes or less. So, x value is less than or equal to 2. So, if you want to know p of x less than or equal to 2, you have to substitute into that distribution, that is that cumulative distribution function 1 minus x value is 2. So, it is 0.488, it is 0.4866. So, this one. So, this shaded edge. Suppose if you want to find out the time between two successive arrival of vehicle is less than 7 minutes, right, probability will increase. So, when x increases, what is that, there are more chances that the time between two successive arrival is this much. So, what I am saying, this is a way to interpret the exponential distribution. Now, there is a very important relationship between Poisson and exponential distribution. See, the Poisson distribution provides an appropriate description of number of occurrences per interval. So, one interval is there, in that interval how many occurrences has happened, that is the Poisson distribution. In the exponential distribution provides an appropriate description of length of the interval between the occurrences. Suppose in the same interval between this occurrence to this occurrences. So, this phenomenon is explained with the help of between two occurrences. This phenomena is explained with the help of exponential distribution. Number of occurrences in that interval, it is explained with the help of Poisson distribution. That is a relation between Poisson and exponential distribution. So, mean of a Poisson and mean of a exponential distribution, what is the relationship? Because the average number of arrival is 10 cars per hour, the average, so if it is a 10 in that interval, there are 10 cars are arriving. So, this mean is taken for the Poisson distribution, but 1 by 10 is taken as the mean for the exponential distribution, that means time between arrivals. So, that is the link between mu. Generally we write mu mean for Poisson distribution, one by mu mean for exponential distribution. That is the relation between Poisson and exponential distribution. Next we are entering into the very important distribution, that is a normal distribution. Normal distribution is, we can say, a father of all the distributions, because suppose some phenomena is happening, if you are not aware, you can assume that it follow normal distribution. Normal distribution is following bell shaped, it is symmetrical, mean, median and modes are equal. The location of the normal distribution is characterized by mu, the spread is characterized by sigma. The random variable has an infinite theoretical range, that is minus infinity to plus infinity. The density function of a normal distribution is f of x equal to 1 divided by root of 2 by sigma e to the power minus 1 by 2 x minus mu by sigma whole square, where e is mathematical constant, value is 2.71, pi is the mathematical constant, we know that 3.14, mu is the population mean, sigma is the population standard deviation, x is any value of the continuous variable. Then shape of the normal distribution is, by varying the parameter of mu and sigma, we obtain different normal distributions. Dear students, what we have seen so far is, we have seen some of the discrete and continuous distributions. In the discrete distribution, we have talked about the binomial Poisson distribution. In the continuous distribution, we have seen exponential and uniform distributions. In the next class, very important distribution, that is normal distribution, that we will cover in the next class. Thank you very much.